Welcome to solverfy.
This is the answer to Chapter 19, problem number 61 from the Smith Organic Chemistry textbook. And this problem gives us the three molecules A, B, and C that I've drawn here. And it gives us three sets of carbon-13 NMR spectra, numbered 1, 2, and 3, which I've drawn or written out in red to the right. And we're asked to match the spectra to the molecules. And so in order to do this, we need to remember that carbon-13 NMR tells us about types of carbons in a molecule. So for each type of equivalent carbons, we get one signal. So when we look at A, what we see here is that there are three types of carbons. So we have type 1, which is going to be the three methyl groups. And I'm just arbitrarily assigning numbers here. We have type 2, which is the tetrahedral carbon in the middle there. And then we have type 3, which is the carbon of our carboxylic acid. So looking at the spectra, spectrum number 2 has three signals in it. And so for A, the answer is going to be spectrum number 2. Three signals, three types of carbons, and there we go. So then looking at B, every single one of these carbons is unique. So 1, 2, 3, 4, and 5 for the carboxylic acid carbon. So 5 unique carbons here. So we need a signal or a spectrum with 5 signals in it. And so that's spectrum number 1. And so B is going to be 1. And then looking at C, we have one type of carbon in these two methyl groups. They're equivalent, so they're only going to give one signal. A second type of carbon would be the carbon to which those methyl groups are attached. We have a methylene carbon next. And then we have a fourth type of carbon in our carboxylic acid. And so this is going to correspond to spectrum number 3, which has 4 signals. And we have 4 types of carbons in molecule C. So spectrum 3 for C. So again, that's A is spectrum 2, B is spectrum 1, and C is spectrum 3. And again, the way that we arrived at that answer was to count the number of unique carbons in each of these molecules and then match that up with the spectrum that had that many signals. And that's the answer to Chapter 19, problem number 60.